So exponents is one topic which we already discussed in the previous sessions in the lower classes. Let's revisit exponents because some of its properties are very important in understanding this topic. So revisiting exponents. What are exponents? What is it about the word exponent in mathematics? Exponents are those numbers which are expressed in power form. The most simple thing is that if I have, say, 8, I can write this as 2 power 3, which is called the exponent form of writing the number 8. This is how we understand exponents. It's very simple that I can write this as 2 power 3, and therefore 8 expressed in exponent form is 2 raised to 3. So using the exponents and the base, I generally have exponent which is written in the form a raised to the value b. In this case, this is said to be the base and this is said to be the exponent, which makes me understand that exponent is nothing but the power form, the power. So this is the base and this is the exponent or power. We indirectly also sometimes refer to exponent as power, is what I understand exponent. So sometimes we need to find the importance of exponents in mathematical problems. So what is the significance of exponent in math life? Exponents help us in simplifying the values usually when multiplications are considered. Say for example, if my question is to find 16 times of 64 without actual multiplication. The actual multiplication would be quite easy if you take a calculator and type and you get the answer, or sometimes by just doing it with the multiplication process. But if my question was to find this without actual multiplication, then that would definitely include exponents connected to identifying the value of the multiplication, as out here 16 times of 64. So let's take this and see how I can do it without actually multiplying the two values. Now let me take the first value, which is 16, which can be written as 2 times 2 times 2 times 2, which gives me 2 power 4, 2 raised to 4. So 16 can be written as 2 power 4, and similarly I take the second value, which is 64, and this can be written as 2, 3, 4, 5, 6. I can write this 6 times so that I get this as 2 power 6. So in this case, my value 16 times of 64 indirectly can be written as 16, which is in exponent form as 2 power 4. So 2 power 4 in its exponent form, and 64 in its exponent form is 2 raised to 6. So I get this as 2 raised to 6. And therefore, this by law of index, the first law of index, a power m into a power n is a power m plus n. Therefore, this finally gives me 4 plus 6 is 2 raised to power 10, is what is the value I get when I multiply this with this. Now this is called the exponential answer for the given problem. Now how do I find the general value of this? It is simple that I take this 2 power 10 as 2 multiplied 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So I take them definitely by taking 2 2's 4, 4 2's 8, 8 2's 16, 16 2's 32, 32 to 64 times 2 128, 256, 512, 1024. So every time I double the value, what I get, whatever I get here, I double here, double, 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 double. So 10 times you double 2, finally I get 1024. Now this is strictly done without the actual multiplication. If my actual multiplication, let's see if I get the exact answer for verification through 64 times 16, 6636, 4 ones 4, and 6, 4, 12, and this is exactly the same answer. This is by actual multiplication and this is by exponential form, is how we understand the significance of exponents in real life. So logarithms are always said to be connected with exponents. No exponents, no logarithms, and no logarithms, no exponents. So therefore, when we have discussed about exponents, revisiting exponents from the already learned topics from the lower sessions, then now we are going to see how logarithms and exponents are connected through a revisit of logarithms. So revisiting logarithms, I just have one of the most important property which connects logarithms with exponents, and it is this. So these are the two important formulae which connect the exponents with logarithms. That is, when log a to base b is c, the value of log a to base b is c, then when you convert this to exponential form is indirectly read as a equal to b power c, where here in this case b is the base, c is the exponent. Therefore, when I just connect this with the left hand side of the property, I see that the base will be the base of the logarithm and the exponent will be the value of the logarithm. So when I connect these two things onto the left hand side, I understand that base of exponent is nothing but base of logarithm out here. So base of exponent will also be the base of the logarithm, and secondly, exponent or power of this exponential equation will be nothing but the value of logarithm. Of course, here this being c and this being b, is how I understand the difference between the base and exponent, between the logarithms and exponential equations. So these are the concepts through which I can convert any logarithm value into the exponential form or any exponential form into the logarithmic form.